Hey guys, what's up? So yeah, I'm home. My oldest daughter Kennedy's got a little cold stuff going on, so we got her a COVID test yesterday. We're just waiting to see the results. I'm sure it's all fine. But anyways, so I didn't want to just leave you guys out in the dark, so I'm gonna walk through these notes. I'll post this. Obviously, you found it. It's on Schoology. So here we go. Okay, so new chapter tests are graded. I'll get them back to you guys tomorrow when I come back to school, hopefully. So here's your new note packet that the sub hopefully gave you guys. You can see we're just going to run through sections this week. And then when you guys come back after a long, nice weekend, we're going to have some quizzes, back-to-back team quizzes. Then we'll spend some time going over all those. Maybe throw a frappy in here somewhere. Go over practice tests that we can start whenever. And then test on Monday the 13th. Okay? All right. So I will try to get this, keep this quick. It's not too bad. Hopefully around 15 minutes or so. So what we're going to do is we're going to use some graphs that we learned about chapter one. We're going to talk about percentiles. You guys have probably heard this if you've taken the SAT or the ACT. They always report back your percentile. So what a percentile is, it's real simple. It just points out the percentage of observations that are less than or equal to it. So if you were in the 95th percentile on your math SAT score, that means that that people who took that test, 95% of them scored the same or less than you. Okay, so given this stem plot, which now we're familiar with, you've got wins in Major League Baseball finding and interpreting percentiles. The stem plot shows number of wins for each of the 30 Major League Baseball teams in 2016. So there's 30 teams, and here's all the number of wins. Okay, they include their key as always, and let's find the percentile for the Detroit Tigers, who had 86 wins. So simple stuff. We'll go to 86. Okay, now there's clearly three of them. So let's take this guy, and what we're going to do is we're going to count how many teams out of the 30 scored the same or less, okay, with 86 wins. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so 20 teams out of 30 scored 86 or less wins that season in 2016. Clearly, that's going to be 0.67, which would be 67%, approximately, right? 2/3 is repeating. So it says, find the percentile. We got it. What does that mean? If you wrote a sentence here, you would say 67% of all Major League teams had 86 or less wins in 2016. Okay, simple stuff. We're still doing simple math here, but it's all about that sentence. Okay, then the second part here is they say, all right, well, the number of wins for Cleveland Indians is at the 90th percentile. So if they're at the 90th percentile, interpret this value in context. So 90th percentile means that the Cleveland Indians how do we want to say this here? So Cleveland Indians had a number of wins, right? Where 90% of teams were below or equal to their wins. And I'm sure you English people could say a better sentence, but it's 2:50 on a Sunday, and I don't want to be in my classroom. How about that? All right, cool. So how many wins did the Cleveland Indians have? Okay, so if they had 90th percentile, right, and there were 30 teams, they had 27, right? 27 teams had less than or equal to their number of wins. Okay, so what I just did, you guys, is it told us up here that there are 30 baseball teams. right? Well, if the Cleveland Indians had a 90th percentile, that means that if you take 90th percentile times the number of teams, right, that would give you 27 teams that scored the same number of wins or less. So if we count up from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, right? If they had 94 wins, therefore 94 wins. If they had 94 wins, right, we would have calculated their percentile by what we did in part A. We would have counted all these, which would have been 27 out of 30, giving us our percentile of 90. Okay, so simple stuff. You should be able to calculate a percentile, and then given a percentile, work backwards, right, given some type of graph. All right. Another graph that I can't, to be honest, I'm not sure that we've talked about this. It's a cumulative relative frequencies. So I know we found relative frequencies, but it's skipping my brain as to whether or not we talked about this. But it's kind of like this segmented bar graph idea. Like on the left, you have percentages, right? And on the right, you're just keeping track of as you increase your relative frequencies, right? This would be 100% of all household incomes. Okay, so up here it gives that formal definition. It says it plots a point corresponding to the percentile of a given value in a distribution of quantitative data. Consecutive points are then connected with a line segment to form the graph. Okay, so this will kind of explain what's happening here. It says this shows the distribution of median household incomes for 50 states and the District of Columbia in a recent year. Okay, use the cumulative relative frequency graph for the state income data to answer each of the questions. At what percentile? So you're trying to find a percentile, right, which is on this side. Is California given a median income of $57,445? Now we know median, right? Half the people in California make more than that, half make less. So since you're given an income, you start on the income axis. And if you go to roughly 57 and a half, right, this is right somewhere right about here, okay? If you go to that part of your graph, and you go directly up to your cumulative relative frequency. They sometimes call this an ogive graph, which is really weird. It's very simple to use. You go straight up from your income value, and it hits the graph right here. And if you go straight over from there to the axis, the y-axis, it will tell you at what percentile that median income is at. So you would say approximately 80th percentile. Okay, so using an ogive graph is really easy, or cumulative relative frequency. That's a mouthful. So if you start with an income, go to your income axis, go up to the graph, your corresponding percentile is there. The only other thing they could do is estimate and interpret the first quartile. Well, that by definition, right? First quartile is 25th percentile. Right? We know that quartile 1 is 25% of the way up the data. Okay, so this is just the opposite question. They're saying, all right, now come over to your graph. 0.3 is dead center here, so it's probably more right about there. So if you were to start at the 25th percentile and go over to the graph and then down, it looks like that corresponds to a household income, median household income of approximately 45. So this would be approximately 45,000 median income. Okay, so simple stuff, right? We got the definition of percentile. What does that mean? And I think you guys have probably all heard of that. And then just using some graphs to get it. Okay, where this lesson and the last part gets more interesting, right, is we're going to start doing standardized scores. And so basically, you know, this is the beginning lesson of what we're going to use the rest of this entire class. So you definitely want to make sure that you're kind of, if you're sleeping, you wake back up now. Okay. All right. So what is a standardized score? A standardized score, you guys, just in basic English, is you collect a bunch of data on female heights, right? We might want to not have that data in terms of height. We might want to have it standardized so that we can look at this distribution and say things based on, right, what we call a z-score, which is a standardized score. Okay. And it tells you, right, exactly two things, you guys. It's really important that you know this. A z-score tells you two things. It tells you how many standard deviations from the mean, okay, and what direction, right? And so we're going to talk about positive, right, above, or negative below. And it's super easy to calculate, right? You just take your value, right? You take the height of some woman and you would subtract the average height, and then you would divide by the standard deviation of all of the data, okay? So let's see how this is kind of played out here. It's just a very simple introduction to this, nothing weird yet. So we're talking about, again, going back to that chart in 2016, okay? The mean wins for all the teams was 81, okay, and a standard deviation of 10.7. Hopefully, when I give you guys your test back, we can talk about this in regards to the class average, right? The class mean and the class standard deviation. Then it says, look, Chicago Cubs broke the curse of Billy Goat by winning the World Series in 2016. Find and interpret the z-score for the Chicago Cubs, who had 103 wins. Okay, so our formula here is z is equal to x minus, I'm going to do this symbol here divided by that symbol. This guy is called the mean, and this symbol is the standard deviation. And we'll talk more about this when I'm actually in front of you and I know that you're awake. But this is, it could be X bar if it was a sample, right? Or it's that symbol for a population. Same thing here. We used an S with a little X before. That's from a sample. This is the population because we're talking about all baseball teams. Okay, so all we need to do is plug in to find Z. It's very easy. X is your data point. So it's 103, right? Chicago Cubs had 103 wins. Minus the average, that season was 81, divided by a standard deviation of 10.7. Very simple calculation, old school calculator stuff. Make sure you guys do not do 103 minus 81 divided by 10.7. That is not going to go well, right? Order of operations is going to divide before it subtracts. So you guys either hit alpha y equals enter, and you type in 103 minus 81 and put it over 10.7. That's how I do it, and I get 2.06. Okay. This number, right, by definition, tells you two things. How many standard deviations away from the mean this data point was, and which direction. So since it's positive, it would be above the average of 81. Okay. If it can be negative, which just means it would be below it. Okay. So you would say the Cubs, with 103 wins is 2.06 standard deviations above the average number of wins of 81. Okay. And so we don't really know what that means. Like, is that good that it's 2 standard deviations above? Is it bad? Right? Being above average in general, right? You guys get that. It's good. But this will be more evident as we learn more about what does it mean to be 2 standard deviations away from the mean. Okay, so we'll kind of get into that at some point, but we're not there yet. So all you're supposed to be able to do is calculate a simple number and then state the two things that it tells you. Okay, this is a typo here, you guys. This should say negative 0.28. Okay, so let's cross that out. Okay, so last thing today before I let you guys go, and again, I'm sorry I'm not in class. I hate not being at work, but it's all good. So now they gave us a z-score, right? So this is like the good old days in algebra, right? They tell you to find the area of a circle when radius is 2. Okay, do it again. Radius is 3. And then eventually they give you the area, and they say, hey, work backwards and find the radius. So all that's happening, you guys, instead of giving you x, they're going to give you z. And then you can work backwards with the mean and standard deviation, right, to solve for that unknown variable so you can find the actual number of wins, right? So this is find x. So if you start with this formula, it's very easy. There are 1, 2, 3, 4 unknowns. We have 3 of them. Z is negative 0.28. X, I don't know. I know the average was 81, and the standard deviation of all teams was 10.7. Okay, so simple algebra. You want to multiply both sides by 10.7. And when you do that, you get negative 2.996 equals x minus 81. And then when you add 81 to that, you get 78.004. So approximately 78 wins. Oh man, happy Monday, you guys. I saw the Instagram page of the crazy football game. Looks like it was fun. One of these days, I'm already trying to rally some friends to go to homecoming. So hopefully that'll happen. All right, you guys, have a great day. I will see you tomorrow.